this column. So here, the tributary area, you type it 1200, which is correct. Now slab. So this is slab thickness is what's called it. Since we are using the composite slab, right? And you type it 3-inch metal deck and 3.25 lightweight concrete. But for calculations, because the slab is corrugated, so from concrete topping is 3.25, and metal deck is 3 inches, right? So what is the equivalent flat slab? Let's say half, because the metal deck typically is 1 foot on center, and this width of the deck value 6 inches. So in order to calculate the area and the equivalent slab thickness, so we take only half of the metal deck and concrete topping. So 1.5 plus 3.25. So this is 4.75, right? So 4.75 inches is equivalent our slab thickness for weight calculations.
So just to clarify,
so
the reason why it's half
yeah,
is because of the deck, how it goes up and down, so that you lose space there.
So
Okay.
this is cross section area. You see that it's not flat solid deck, right? This is
Right.
corrugated. You have typically 6-inch, maybe metal deck. If you can, I think if you see the metal deck manual, or this is just physics, or not even physics, just math. When you look at the cross section area, we have various depths. I mean thickness overall. So we have to just find out the equivalent thickness to convert it equivalent flat slab. So this case, you have to use 4.75. If you choose 3 plus 3.25 3-inch metal deck, 3.25, and a lightweight concrete slab, right? So if you choose this system, and you have to use this slab thickness, now it calculate. I just use 115 pound per cubic feet for density. So I added. Basically here, I may have to add another 2.5 PSF for weight of metal deck. I'll just add it 0.5. I didn't add it before, but you see that slab thickness and equivalent associated slab weight, area weight, right? So 4.75 inches is equivalent flat slab thickness divided by 12 compared to feet multiplied by density or weight, 115 PCF, and then add the weight of metal deck. So this is you initially you may have to adjust depends on how you calculate it. If this is concrete slab, concrete framing, you are doing it, you have to do it right. Obviously, you have to include your flat slab thickness instead of this calculation. So this is just for this exercise. since for composite floor framing, I think turbidity area is supposed to be same. Slab thickness, you have to depend on the system, and other one is strap force, composite dead load, and live load. So you should calculate is 1.4 dead load cumulative load, and also 1.2 dead plus 1.6 cumulative dead load, and you take the worst one, right? So that is here is governing PU is maximum governing actual force for your column design. Now this is just one example. Okay, just show. Oh, we're gonna use or engineer this decide that we're gonna use eight concrete strengths 8 to 6 rebar 60 ksi. Now is a column size. So,
Professor, so
but this case is the concrete column, but we are not using concrete column. But if this is a concrete scheme, I think you have two choice, right? You have two factors: increasing sizing the column cross sections, or also you have number of bars. But here I'm just playing with area percentage of rebar on the cross section area.
Professor,
So now here you just based on yes.
um, for the concrete strength, we used 4 KSI. So should we change that to 4 for the?
Okay, that is something I need to because now we haven't designed the stiffness our core wall system yet. We haven't
Okay.
sized any core wall yet. So this is just gravity floor framing model, right? Just your wall, you don't size at all. Nothing has been done. But yeah, I noticed that because you don't have to define all the material at this point for the wall, just some typical wall and concrete strengths. I think it's okay because you're just only this model is only just gravity framing design purpose. After you, I know that you just send me that entire model, I'll just maybe copy here. Lateral model. I'm gonna select all, replicate, and oh, wait a minute, this model, oh, we don't have flow data yet. Oh, we don't have flow data yet. Okay, then I'm gonna use your model. So let me just go back to spreadsheet, just briefly talk. So eventually, so far we only done the gravity flow framing design, right? Your core wall has been done any lateral design. We haven't done anything. So which is now time to move to. But as a structural engineer, I give you a lot of information at this point. But eventually, I know that we need significant wall thickness and then concrete strength and rebar, maybe because based on experience, but also eventually you feel this, right? Based on this Excel spreadsheet, right? Your column, if you're using concrete column, let's say if you're designing a concrete building, you see that you need to design the column sections, right? Dimension, and also rebar. You see that this is stress level. So this case, okay, you may be and you'll be interested. Okay, what about 2% of rebar? Still, you're not that close to the your capacity. So obviously, you may be able to increase the column. Something like that, right? So you see that based on the stress level, I mean, this demand, which is your force, what and versus your column capacity. So as you just use design, that means sizing the column and rebar. I think you keep design that along the height. So let me here. Let me just for okay. So 42 by 60, and you keep maybe using 2 or inches or 2 inches variations. So you could design along the height like that, right? Right. So this is the column design. We have to sizes, but also rebar. But there is a maximum rebar ratio up to 3 and 4, especially 4. But 4% is pretty dense. So practically, we don't design the rebar that much. We don't design the concrete column with that high steel ratio, because it's I have a congestion related issue. Maybe practically as most 3% might be. That's 3% of steel. I also need a coupler. If you just use typical lap splice, I think that you end up the congestions, so it's hard to pour the concrete, and you may have some practical related issue. So typically 1 to 2%, maybe that is pretty typical steel reinforcement ratio for the column. But then if you just choose to maybe as maximum of 2% steel, then you could try design, and you can size the column, right, based on the capacity. Okay, so just you understand this, right? This is column design. This for uh, concrete column, concrete module. So you just do from the bottom to up and see for column concrete case is width and depth. You can just reduce along the height, maybe every 2 inches or 4 inches, something even number, which is okay. But you just go with some more practical reinforcements, less than maybe 1 between maybe 1 and 2% is pretty common. And then move to the steel. Our case is our interior bay 40 by 30 is so high. I don't think we can find out full section.